Can NLP techniques be utilized as a reliable tool for medical science? Hello everyone, let me introduce myself. I am Sumaiya Tasneem from Silicon Orchard Research Lab, Bangladesh. So here is the key points I am going to represent throughout the presentation. Their introduction, our research aim, our proposed framework, data and experimental result, limitations and future work. In artificial intelligence, natural language processing is a specialized field which deals with textual data. Inevitably, textual data dominates over image or numerical data. But as you can see, in the field of biomedicine, bioinformatics, and genetic engineering, there are various medical applications on genetic sequencing, gene structure presentation, or medical image analysis like CT scan, X-ray, etc. Comparing the number of image-based applications, is there as much text-based applications in machine learning? Here we have mentioned a few notable NLP-based applications, which are text mining, POS tagging, information retrieval and extraction, identification of protein or gene names, annotations of medical records. There are also applications on medical document classification into groups like ultrasonography, endoscopy, and X-ray, etc., and also statistical text classifier to detect extreme or risk events. What is our research aim? Our research aim to answer to the question which I have already asked you earlier is that can NLP techniques be utilized as a reliable tool for medical science? Our proposal is to construct a reliable framework for classifying medical records. Here is the details of our proposal in the diagram. As you can see, it is comprised of two portions, training and testing phase. In the training phase, we give users the privilege of training the system with their specific data given in required format and perform a comparative analysis. If the user does not have or does not wish to train the model with their dataset, they can use ours by default. The first step is data cleaning. To clean data, we have used various preprocessing techniques, which includes removing stop words, removing duplicate entries and missing entries, lemmatizing the texts, lowercasing the textual contents, checking class imbalance, etc. If the dataset shows a class imbalance, we implement data augmentation for each class, followed by random data shuffling. Then comes feature engineering. The textual content from the clean data is then used for feature extraction with various techniques like principal component analysis, bag of words, conditional informatics learning. After these pre-processing steps, there goes the main portion where we have implemented 3 deep learning classification and 4 traditional machine learning classification algorithms. To implement these algorithms, we have used an ensemble approach, which means we have combined several base models in order to produce one optimal predictive model. The dataset is divided into training and validation set. Though the ratio of the split depends on the size of the data, by default we apply 90-10 train-dev split. After the models have trained on the training data, we measure the performance of each models using confusion matrices and calculating F1 scores. A meta information, which means training time performance scores parameter used for training, is then created for each of the models and arranged in respective to the performance on the validation data. Least performing models are retrained again with hyperparameter tuning, and the results are updated. This is then temporarily saved our local database. Then comes the testing phase. Here is also a data cleaning step which exactly works as the training phase. After that, 5 models will be pulled from the local database based on test data features. In spite of selecting top 5 models, we will use a genetic algorithm to select the combinations of a different set of models that perform based on separate objectives such as accuracy, time, and computation cost. The results are then ordered according to majority rule, which means the class that appears most among these five models and the result of the top performing model is also kept as a base reference. The result is then stored in the user database. After test is completed, the system provides a formatted report on the classification outcome as well as readable summary of the model outcomes. Here is a brief explanation of ensemble approach, where the algorithms are shown which we have used on data. After passing the data through the algorithms, we have calculated a weighted average and finally got the result. Then comes data and experimental result. Here is a sample from the dataset for medical transcriptions with specialty classes. Here are four classes named cardiovascular or pulmonary, surgery, orthopedic, and lastly consult history and physician. From this figure, we understand the existing number of data from each target class. It is showing that surgery class has comparatively more data than the other classes. To fix this imbalance, we have used data clipping methods and also used Markov chains to generate texts for the other three classes using only class-specific texts. We also used some common techniques of text preprocessing like removing stop words, lowercasing all the texts, removing punctuation marks, etc. and have found out that removing punctuation marks only gives a boosted accuracy by 2% compared to removing stop words and lowercasing the data. Here is the performance scores of algorithms in ensemble approach. In this implementation, all accuracy of the algorithms ranges between 78 to 82% except the unidirectional LSTM. Here are some confusion matrices of our best performing algorithms. Among the implementations of the algorithms, universal encoder, k-nearest neighbor algorithm, and BERT perform the best. Our proposal have some limitations too. As we are working with medical data, it is hard to collect rich and diverse dataset due to the sensitivity of medical data and the rules of HIPAA compliances and GDPR guideline. Also, existence of bias due to class correlation limits the change of getting appropriate data. So, in future, we would like to add improvements on algorithms through hypertuning and optimizations. Also, we are aiming to create a web framework which will be accessible to both doctors and patients and collaborate with hospital to collect a dependable dataset. Lastly, we expect that even though this framework is targeted for patients or users, in general, doctors can also be benefited as this can save valuable time through automation. Thus, another contribution can be added in text-based application in the field of medical applications. Thank you all.